Okay, in this clip, I'm going to walk through an example of an F-test from beginning to end, following the instructions that I've shared with you in previous weeks. I'm going to be referring to a handout called Another Example by Hand. I know that's not a very exciting title, but that's what it is. It's another example by hand, and it looks like this. All right, so if you don't have that handout, please go to Blackboard, pause this video, go to Blackboard and access it somehow, either digitally or print it out so you have it. I don't think it's going to take a tremendously long time to walk through this because I'm not going to walk through the math necessarily step by step. I'm going to leave that to you to review. The math, as I've noted earlier, is fairly straightforward, but it is lengthy and it's very important to pay attention to detail. The null hypothesis we're testing is as follows. H sub 0, null hypothesis of equality. Freshmen, sophomores, juniors, and seniors, so 4 groups, freshmen, sophomore, junior, seniors, are the same or equal regarding the hours they work outside of school. And you are asked to test the null hypothesis at the 0.05 level. Now, this is different from the example I gave earlier because here I'm not just giving you the data generated F value. We're actually going to calculate it, or it's calculated via this handout. But the first thing I want to point out simply is I've organized the data the way they should be organized for really any F test that's going to be conducted by hand. I've got my 4 groups represented by 4 columns, so I created 4 columns, freshman, sophomore, junior, and senior. And then below each column header, I've placed the raw data. All right, so in other words, there were 5 freshmen, and they reported working 10 hours, 8 hours, 0 hours, 5 hours, and 20 hours. See, right there. There were also 5 sophomores involved in the analysis, though keep in mind, you do not, as I've noted earlier, you do not have to have the same number of cases in each group. You can have different numbers of cases in each group, and it doesn't change how you work through the problem at all. But in this example, just to keep things even and parsimonious, I also used 5 cases in sophomores. And so there are 5 sophomores that report working. The first sophomore said 20 hours, second sophomore said 25, third said 15, fourth said 40, and the fifth said 10. Likewise, there were 5 juniors involved in the analysis. The first one reported working 25 hours, the next 20, the next 10, the next 10, the next 20. And last but not least, there were 5 seniors involved in the analysis, and they worked 30. One person worked 30, one person worked 40, one person worked 40, one person worked 25, one person worked 0. So you can see, in keeping with a previous example, as I walk through another example like this, we see that there's variation within each group, right? And there is variation between the groups. All right, so we have 2 types of variation within and between. The next page is the same information, but with all the math conducted. So I still have 4 columns, actually 8, but I've have 4 groupings. This is the information pertaining to my freshmen, this information pertaining to my sophomores, juniors, and seniors. And then under each of those headings, freshman, sophomore, junior, senior, I have the raw data again, X sub 1, and that subscript is simply referring to that as group 1. So X sub 1, that's the raw data. You've seen that before in the previous page, 10, 8, 0, 5, 20. X sub 2, that's the raw data for the sophomores. That's the exact same thing you saw before. X sub 3, that's the raw data for the juniors, 25, 20, 10, 10, 20. And then X sub 4, that's the raw data for the seniors. So all I want you to note here, well, there's a lot to note here, but I want you to notice that the first thing I did was simply repeat the raw data. The next thing I did was create a second column next to each original column, which is X subgroup squared. So this is for my first group, my freshmen, this is X squared for my first group. 10 squared is 100, 8 squared is 64, 0 squared is 0, 5 squared is 25, 20 squared is 400. See? Each raw value squared. Each raw value squared. Each raw value squared. Each raw value squared. All right? Then I added up the raw data, sum of X. I then squared the sum of x, or to use my previous dramatic pause, the sum of x squared, meaning add first, then squared. Then once I had all my squared values, I added those together. So this is sum of x squared. Square first, then add. Add first, then square. Square first, then add. And I did that for each group. Sum of x squared, the sum of x squared. For juniors, the sum of x squared, and the sum of x squared. Seniors, the sum of x squared, and the sum of x squared. So I've got all those very important values down here. Sum of x squared, and sum of x squared for each group. That's all that has happened on this sheet. And this is a very important sheet. It's very important that you have that initial math conducted properly to make sure that you end up with the correct result. All right, so if you need to rewatch this segment, please do so to make sure you understand where each of these summary numbers came from. Raw data, sum of x squared, raw data squared, then added together. Raw data added together, then squared. Raw data squared, then added together. Raw data added together. Raw data added together, then squared. Raw data squared, added together, and so on for each group. Next, I then calculated sum of square tote. SS sub tote. Now, is that upside down? That is upside down. My apologies. This, again, this information at the bottom, the summary information, is where everything that you see involved in that sheet came from. Absolutely everything. It's just a matter of making sure that you're placing the correct numbers in the correct place. So pay very close attention to parentheses. Parentheses are very important in this procedure when we're doing it by hand. The only other thing I want you to note is I circled that number here. That number is the sum of x subtote squared. So that means adding all the raw data in all the groups together, adding all the raw data, the original numbers, adding all the raw data in the groups together, then squaring that and dividing by n subtote. That number, that term, which I'm circling here with my finger, and which is also here, this number gets carried forward into the calculation of SS sub between. And again, I noted that in a previous segment as well. And it's also contained in the handouts also. So I did come up with a number for SS subtote. My recommendation would be that you work through the math yourself and see if that you came up with the same number. SS subtote is 2,932.55. That's the total, excuse me, that's the total sum of squares. Next, all contained on one sheet. SS sub between, sums of squares between the groups. I repeated the formula, which you've seen before. Again, this number here is something we're going to pull from the previous page. All I did here was for each group, took the sum of x squared and divided by the number of cases in the group. The sum of x squared and divided by the number of cases in the group, and then added each of those values up. So that's why you see 1, 2, 3, 4 items here. That's each group. That's the sum of x squared for group 1 divided by the n for group 1, 5. The sum of x squared for group 2 divided by the n for group 2. The sum of x squared for group 3 divided by the n for group 3 plus the sum of x squared divided by the n for the fourth group. Add all that together, or divide the ratios first, add all that together, then subtract that number there, that number that came from our previous calculations of SS subtote. This is just carrying the math through, and I end up with a value of sums of squares between of 923.35. I'm going to cut this off and then create a new segment.